Percent yield. Percent yield is the actual yield divided by the theoretical yield times 100. This is not given to you, so you'll have to remember this. The actual yield is what you actually get. So if you're not trying to solve for the actual yield, it has to be given to you. But it's what you actually get in the lab, what the student measures in the lab. Theoretical yield is the answer to a stoichiometry problem. So it's the math or the tables. You solve it. So it's not given to you in the problem. You calculate it. So methanol can be produced through the reaction of CO and H2 in the presence of a catalyst. That part of the statement doesn't matter. They gave us the reaction. So if we have 75 grams of CO react and it produces 86.4 grams, what is the percent yield? So we know that we have a percent yield problem because we have two givens and they're for one reactant and one product. So that's how it's different from a limiting reactant problem. A limiting reactant problem, you have two givens for two reactants. But a percent yield, you have one reactant and one product. A percent yield is always about the product. So the one that is with the product is your actual yield. So this right here is going to be our actual yield. So we have to take the one that's with the reactant and do math to come up with the theoretical yield. So we take our reactant, and in stoichiometry, the first thing that we want to do is convert to moles. So we want to get rid of the grams. And carbon and oxygen added together have a molar mass of 28 per mole. So now I'm at moles of my reactant, but I don't want my reactant, I want my product. So now I'm going to use my mole ratio to change from my reactant to my product, the coefficients. Now I'm at my product. My actual yield is given to me in grams, so I need my theoretical yield to also be in grams. So now I'm going to change it to grams. So 1 mole, I add carbon, 3 hydrogens, an oxygen, and another carbon, and I have a molar mass of 32. So then I can multiply, I'm at grams of my product. I can multiply and divide, multiply and divide, multiply and divide, and I can get my theoretical yield of 85.7 grams. So to find the percent yield, I take the actual divided by the theoretical, and because I want a percent, we're going to multiply by 100. Grams would cancel, so I have no unit except for the percent sign. So I have 79.8% of C3OH. The larger your percent yield, the more accurate you are in the lab. So if you're working in industry, you want your percent yield to be as high as possible, because then that means you're not wasting anything.